All right, so before I forget, I'll get an announcement on Canvas after class, but I have a meeting at 3 today, so usually I'm in my office 2 to 4. I'll be there 2 to 3, and then 3:30 to 4:30 if you want to stop by for office hours this afternoon. Although probably haven't gotten to work on what I posted yesterday, which is kind of that 4th homework assignment, right? So I don't have the 3rd one graded yet. I'm hoping to knock that out tomorrow. Have those grades kind of up there before we start class Friday. But that next homework is up there. We've covered all the material that you'll need to kind of answer all the questions, so you should be able to work through that already. Due date's kind of a ways down end of next week. So start kind of working on that early, kind of get any questions you have out of the way. Other than that, any questions before we jump into material today?
How many homeworks are left?
So there'll only be one more after this, right? So we'll have 5 homework assignments. The next one, you got last like 2 weeks of, you'll have that last 2 weeks of class to work on. And also I would highly suggest kind of starting to work on those projects and getting those going. So we looked at a lot of papers, kind of the setup now hopefully makes a little more sense, where we're looking at kind of just writing an introduction. It's any paper really. We're going to then do what we kind of call that lit review section. I said you need at least 2 kind of peer-reviewed articles where you're just kind of summarizing them and then comparing them to what your question is or what you're doing. Then the economic principles. This is not so much of like doesn't have to don't try to use buzzwords. Try to kind of think about, is there a model that we've talked about in class or something where I could look at like supply and demand, or am I thinking about what are the incentives of the workers here, or what is the marginal benefits versus the marginal costs? Like that's kind of more of the setup, is explaining what you would expect based off of a lot of the different principles we talked about in class, or in any other econ classes you talked about. Then kind of outlining the data, kind of maybe some summary statistics. If I have, we'll look through some examples today. If I've got revenue data or something, maybe saying what the average revenue was, how many years are in the data, how many observations, like just kind of explain the data a bit, then kind of running at least 1 regression, right? Probably better to have a couple regressions in there, but once you have that regression results, kind of interpreting those regression results and then kind of including that paper. Okay. So there's no questions. I'm gonna jump into things here. Any other questions for me before we get going? How nasty is the weather outside right now? Is it raining or anything? Yeah, windy. Okay. I just started when I got in this morning. It was sprinkling. I started raining much, and I got a tornado watch during my other class, so hopefully that doesn't turn into a warning. So I'll go through these kind of quick, and then we'll kind of shift gears a little bit. This is kind of wrapping up any concerns you would have about paying our players, right? So one thing that we could maybe see be an issue is kind of Title IX concerns, right? So currently we think about I'll probably misspeak on this a little bit, but I believe it's something like for every male sport offered, there has to be kind of a female sport offered. It doesn't have to be the same sport, but you have to have an equal number, right? And so one of the issues with this could be if we go to a model where we can start paying players, well, we know that our 2 largest revenue generating sports are going to be men's basketball and men's football, right? So we don't really have a counterpart. Like the next closest is probably female basketball, but the revenues are significantly lower than men's basketball, men's football. So inherently, if we then allow those teams to start paying players, there's going to be less revenue. A lot of those lower sports, right, lower revenue generating sports rely on those revenue generating programs, but there's not going to be as much money to go around now because they have increased labor costs. Okay? You also could think about, if the amount of revenue at all is kind of correlated with gender potentially, when we're thinking about if I'm driving up the cost of some of these lower revenue generating sports, maybe I drive them out of the market, right? Maybe that their cost increasing will now result in they don't have enough money to be able to support their program, especially given that they're not getting any additional profit or shared revenue from these high revenue generating sports anymore. And it could be that under a free and open labor market, this Title IX doesn't really apply anymore, in which case we would just eliminate kind of opportunities for women's sports as well, right? So this could have some negative effects when thinking about through the Title IX. I also just kind of go through it quick. We also might have some health insurance cost concerns. So one of the stipulations in the Affordable Health Care Act is if you have employees, more than 50 employees, you have to provide them with health insurance. So, one football team is more than 50 employees, right? Even if we treat these sports individually, but the athletic department really is who we think about. So they would have to be offering healthcare coverage to the student athletes, which you could probably argue is a good thing. You can get, CTE by playing football. It seems like maybe the university should also be kind of providing some healthcare coverage. But one thing that this could do is also reduce wages, right? So let's think about it this way. So let's say we've got one of these black markers there it goes. That one's a good one. So let's say we're thinking about a good program and the demand for labor is pretty high and they're able to offer their players a pretty good wage, right? Well, if we factor now they're also going to have to provide healthcare coverage them, what have we essentially done is thinking about this as we're now not only going to pay a player exactly what they're worth to us, right? This is the amount of additional revenue that player is bringing in. But now that player also brings in the additional cost of healthcare coverage, right? So essentially, we can almost think about this like a decrease in our demand curve. Right? So this requirement of healthcare coverage would then actually result in lower wages being paid overall. Now, you can think about also one thing that you could do is think about, well, this wage, one way we can model this in labor markets is this wage is not necessarily kind of the monetary compensation, it's the total value that you're given, right? So you could think about it as, we could include that this wage or have it so this wage includes kind of the value of the healthcare coverage to the worker, in which case, the supply curve would be a little bit higher as well, maybe kind of raising that wage back up to what it should be, right? But we would want to think about how this requirement of healthcare coverage could kind of lower wages overall, right? It may not lower the total value to the player, right? That healthcare coverage still has value, but it would lower the amount of money that they're receiving. Okay? Any questions on that idea before we keep moving here? No questions? So when you think about it as this healthcare coverage, kind of thinking about it as shifting the demand curve. If we're simply looking at wages here on the y-axis, right? We're not factoring in kind of the value of that healthcare coverage to the workers on that y-axis value. Right? All right. Any other questions? We keep moving here. Go back and see that again, or okay. Let's go. Thinking about benefits of being a student athlete, potentially, right? Or kind of the decisions that some of them student athletes will have to make. So what students will benefit the most from being a college athlete? Right? So you can think about this in two ways. It depends on what our objective function is. Let's say my objective function is to, well, because it's the same objective function, two different scenarios. Let's say my objective function is to just simply maximize kind of the amount of money that I'm making over my lifetime, right? What characteristic might result in different values to that student athlete from being a student athlete? So if you think about like a high quality kind of football player, right, in a Division I SEC school, right? What's the real benefit of playing college athletics to that individual? What does it hopefully lead to? Yeah, right. Hopefully it increases their probability going pro. If we think about increasing the probability, well then my expected lifetime earnings, I can think about, oh, I threw this over here, so I didn't do it. The expected earnings would be the probability that I make it to the professional level times, whatever my salary or whatever my contract is at the professional level. And then add to that the probability I don't go pro times the salary of whatever job I get, right? Now, if I'm increasing this probability, I'm assuming it increases earnings because I'm assuming that the salary you can make at the professional level is greater than whatever job you would get otherwise. Right? However, if this probability is relatively low, so instead of this quarterback, let's think about if I've got, let's say I'm looking at a bowler. There's a professional bowling league that you can probably make a good amount of money. Let's say we're just going to look at a low quality kind of football player. They're a backup, they're a reserve, right? Or a bench player in basketball. We think about that as the example. Playing at the collegiate level probably does what to their probability of going pro? So if I'm sitting on the bench 4 years on a men's basketball program at the D1 level, what's happened to my probability that I make it to the NBA? You could think going down, it probably doesn't go down. My guess is it goes from 0 to 0, right? It doesn't matter if I played at the collegiate level or not, my probability is still 0. So when we're thinking about expected earnings for these lower quality athletes, people who don't have that chance of making it to the professional level, really what matters is, well, I know the probability I'm not going pro is 1, so it matters what salary can I make in that other job. So for these lower quality athletes, why would being a student athlete actually be a good decision? Well, they're getting a college degree. And hopefully that college degree leads to a higher salary in the job they get. So it's really a benefit to any type of athlete, right? And then in that context, and we're thinking about just future earnings. But you could probably argue for the higher quality athletes, it's even more valuable, right? Any questions on that idea? It's not too crazy. So, oh, here we go. So if we think about who's going to kind of benefit from having a degree, it also depends on what they choose to do at the collegiate level, right? So if we're thinking about these lower quality athletes, where really the value of being a student athlete is getting this, tuition remission, getting this education, right? It's going to vary depending on what you do, right? The one people always joke about, if I major in finance compared to basket weaving or something like that, right? That is very different expected income once I leave college. So, another thing to kind of think about is not just the major I choose, a kind of broader description. I don't know if any has labor economics. I'm sure you talked about this idea. But even if you don't learn anything in college, right? Let's say you get through, you pass your classes, you don't retain a single piece of information, right? Like, I mean, there's Google now, right? I can Google anything, and so whatever. Well, along the way, I mean, I guess there is a scenario where this doesn't occur. But as long as you passed your classes, the process that you had to use to complete assignments, to study for exams, even if you don't remember that exact information, you worked a neural network to be able to learn things of a similar caliber, right? You've done it once, you've learned the critical thinking skills to be able to apply to anything else. So if you're thinking about even your own job market opportunity prospects, a lot of the times your degree is just a signal of quality, right? It's not a signal of how much you're going to know day one when you start that job. Now, in some fields, they might be like, well, not going to remember everything, but we hope that you can remember, this set of information. But a lot of the times they're just using it as a signal, right? So for instance, if you can show that I can pass classes where I was having to use Excel or using some other data management programs, that's a signal to them that, well, you have the capability to work on these types of things in Excel. We can teach you how to learn data management in a different program, right? And so it's just a signal, right? It's not necessarily increase your human capital, right? So either way, we can think about this as, once you get the job, well, then it's, doesn't matter that you have the degree, it matters what your performance in the job was, right? So that education, even if it doesn't build human capital, it's a signal that allows you to get that better opportunity. And then kind of once you're in the job, it's just based off your performance. So the students who are probably going to benefit more, like let's say, I don't think this is a wild assumption. Let's say that some football programs or football players in large kind of Division I programs get their college degree and were kind of handheld the whole way through. Right? Maybe, there was some tutors are doing a lot of work or whatever it is, right? Potentially, once they've got this degree, they've got this signal, but then once they get a job, performance is poor, they're gonna lose that job, not have as great of opportunities. So the students who are really benefiting from this is gonna be our kind of higher ability students who actually did pass, and kind of learned a little bit more along the way, and are able to perform better at the next level. So it's not necessarily that having this degree is always gonna be valued, right? But like I said, I would argue more often than not, right? There's gonna be, some positive values to this. It's just that it's gonna be lower for our lower kind of academic ability kind of students versus our high academic abilities. In fact, so this is kind of an interesting paper. It found very different things. So it basically was like running like my Y variable was salary or wages that someone was earning. Had some controls, and then my right-hand side variable, they just started including indicators for what type of major you chose. And I think they grouped them together. So like they grouped STEM jobs, they grouped some of the humanities, the hard sciences. So just 1, 0 variables, and then looked at those coefficients to say, okay, if I got a STEM job or I had a STEM degree, science, technology, you're in math. Yeah. So, so 1, 0 variable, if I had a degree that was considered a STEM degree, here's the expected increase in my wages I expect to make. And I think they were using like starting salaries. What's interesting is they found that being a student athlete, right? We know that STEM jobs increase the amount of money, right? So they kind of did this to prove this. So write this out just so we have some context and not just just not my words. So we could estimate the impact of these different degrees, right? And we can find that for some of them, we're going to have a positive amount, but if I do like, I don't know, I'll pick on the humanities, right? If this is less than 0, right, I might expect they, relative to kind of whatever group I leave out, may have a little bit lower salary. What they then says, okay, look, what if we look at being a student athlete, what's the impact that has on salaries? And then kind of break this up by these different groups, right? Maybe only run a regression for the STEM majors versus other majors. And what they found was that for STEM majors, being a student athlete led to higher paying jobs. But for some of these other kind of areas, these other majors, they found that being a student athlete had kind of also led to potentially lower kind of starting salaries than on average, right? And this might be something along the lines of, well, yeah, if I'm a student athlete and they're making any type of kind of lowering the standards, I'm going to inherently have lower academic ability individuals in those positions. They're going to choose lower paying majors. And so they're relative to a non-student athlete at the college, they're actually going to end up with a lower salary. And we can actually see this kind of maybe how this is being driven. So business and other related majors, most popular degree for a lot of student athletes. But you can also see like some of the other ones that are relatively high, like comm and then sociology, social science, and kinesiology. All 3 of these, maybe with the exception of communications, very low starting salaries and even mid-career salaries. Like my brother, I can say this without I don't feel mean about it, because my brother actually is a professor as well in kinesiology. And so, he tells me that, at the undergraduate level, like a degree in kinesiology is like almost worthless. I mean, it's just not worthless, but like, unless you get additional schooling, like you go for your master's or for your graduate degree, there's really not a whole lot of job opportunities. You probably could have been an athletic trainer for 4 years, you already not athletic trainer. You could have probably been like I don't know, like a trainer at a gym for 4 years and probably have just as good of career prospects, right? So these are going to be really low paying jobs. So if we know there are a lot of student athletes choosing business degrees, those are generally leading to higher than average expected salaries if we kind of compare it to other majors at the university. But we also have athletes over selecting into lower paying majors as well. So that's why when we run these regressions to see, well, what's the impact on salary of being a student athlete? The answer is depends, like everything in economics, right? Depends on what, I'm more likely to choose a better major, but they're also more likely to choose these lower kind of end majors as well, right? And then kind of down, we can break this down by different categories here, like we're going down the list. But yeah, you can kind of see the most popular here, business, and then kind of these lower paying fields. Any questions on this idea? Or thoughts? I don't know. What's a potential so what's one thing that you notice here that the proportion of people choosing that path was probably different from kind of just the general non-student athletes? One of these was like a lot larger than I expected it to be. There's one of these categories that I don't even know what you do with. I don't know. You do see it general, you like general studies or you, I mean, hopefully, you know, these are completed degrees, right? This is, I mean, you know, not that hopefully no one in here is that, you know, it's one thing to start out that way, but to just have a general studies degree. I mean, yeah, maybe it's a little bit of a signal, but like, you know, I can't find a really good explanation to, you know, I don't think there's an explanation that can convince me that any of these degree holders are going to be expecting a higher value or higher salaries in the future, right? So I don't know, are we doing a disservice to those student athletes if we're allowing them to kind of choose these lower? So I tell the story at Purdue. I knew this guy, and he was a wrestler, and I'm convinced that, like, I don't know how he even got accepted into college, let alone got a 4-year degree. And it was the same, he did general studies, and it was just like these classes, they called them organizational leadership classes. They were like, he would show me the work and it was just a joke, right? They were basically courses that were created for student athletes, to be completely honest, right? But you know, that probably doesn't occur at universities that are generating lower amounts of revenue, right? They're probably not lowering their standards as much, but when you're looking at these large D1, Big Ten, SEC schools, a lot of that is going on behind the scenes, right? And you're probably doing those students potentially a disservice. They now think, well, I've got this degree, I'm gonna be able to go out and earn these higher salaries. Well, it's not the case if you got a general studies degree, right? In fact, even if that is being used as a signal, once you then get your first job, you're not going to be able to perform at a high level and you're probably going to lose your job, right? So I don't know, just some different things to kind of think about. The next thing that we're going to transition to, kind of play around with the numbers a little bit, some interesting things to think about, which is if I play at the collegiate level, what's the probability that I go pro? Okay, so I went and pulled these, I think these are in 2000, it was right before the pandemic. But it was like this survey of NCAA athletes and that they could track them. So I don't think it was like every single athlete, but they had a large majority, right? So you had the number of people drafted. It kind of had these different sports. And you can kind of see across every D1 university, the probability if you play at that D1 university, and obviously it would vary depending on what university you're at, but just as a whole, you have about 9% of baseball players getting drafted, 1%, you know, 1.5% for football. So these are relatively low probabilities. Why do you think baseballs might be a little bit higher?
They have like 30 something now.
They have 30 rounds. Why do they have 30 rounds?
Over division.
I said they've got several divisions that are technically considered the professional division, right? Professional level. So we're just, you know, it's almost like multiply these by 4, and then it's a little bit more comparable, right? They're just filling out these rosters for the minor league teams. Okay. So what's a little bit more interesting is the percent of these players who don't just go to our major professional level, but kind of considered any professional level, like any level past college where they're getting paid to play the sport. So why do you think that probably increases basketball by quite a bit? Euro leagues, there's, you know, there's leagues in kind of Asia, there's everywhere, right? And so in fact, it wasn't too long ago, I'm not gonna remember the player who it was now. It was just like some average run-of-the-mill player in the NBA, and he left to go to I think China, and was making a ridiculous amount of money, right? There's a lot of opportunities overseas. Okay. Excuse me. No, there was some. It was a guard. It might have been him. I follow a lot of the like old Purdue, or I follow Purdue accounts, and every once in a while they'll like put up an old player, and it's like, you know, playing in some Euro league somewhere, so, you know, so there's a lot more opportunities kind of in those sports than others. So, is there anything else I want to say? Oh, so we've got this variation, and this is a percent that you know, the probability of the percent likelihood you get to the professional level, right? If I then look at kind of, well, what's the average kind of salary across these professional leagues, right? When you think about for the average player, what would it be optimal to do? Well, I'll just take the average length of a career times the average salary per year, multiply those to get kind of your average career earnings. If I'm then thinking about, okay, if I am a student athlete, at the collegiate level, what's my expected salary kind of moving forward? We already had this earlier, but a component of it is, well, the probability I make it to the professional level. And now I can kind of think about, here's my career earnings in that sport. So we could start to kind of come up with these expected values of playing different sports at the collegiate level, and which one would kind of be at least expected to be the most profitable, right? Or generate the highest earnings, right? So come down here, think about this. Oops. So that's all I'm doing here. It's kind of coming with that expected income. So you think about like a dual sport athlete, if I'm, you know, just wanting to hone in on one sport at the collegiate level and trying to make it professional level, then really, I mean, if I'm just considering money, right? It's going to be take the average career salary to that sport, multiplying by the probability you make it to that sport. Now, here I didn't use that really high value for Major League Baseball. I kind of reduced it. I kind of, you know, said what's the probability. They had a probability they calculated if you played at least one game at the major league level, right? So this is kind of excluding only minor league players, and you kind of see the expected value from playing collegiate football. I mean, it's about 0.11 million or 100,000. That's primarily because most people don't make it to that next level, right? That probability is pretty small. However, it's all much more likely that you can make it to the professional level playing college collegiate baseball, increasing, threefold, but also the expected average kind of salary for a baseball player is significantly higher. And that's really a byproduct of, if we compare kind of the length of an NFL career to the length of a baseball career, much, much higher. Right? So you could start to do these comparisons for any sport, play around with the numbers a little bit. It's also kind of worth mentioning, we can do this analysis for like expected income for like a dual sport athlete, think about like why would, you know, what should you choose? I think like a more recent example, which is pretty good, is Russell Wilson, who is Tyler Murray, like there are a lot of more kind of dual sport athletes at the collegiate level, which gets rid of, basically there you can think about if you could go professional in either one, it would make sense to choose whichever has the highest average career earnings, unless you have some belief in yourself that you're going to be above the average in one of the sports, but not above the average in the other, right? Assuming that you're of equal quality in both sports, you can see here, like the decision always blows my mind that a lot of these guys are choosing to kind of play in football. And that's only because, you know, it's not a guarantee that you're going to have a long career, right? In Major League Baseball, right? Even if you're average, you can have a pretty long career, or on average, the length of the career is much larger. Also, the salary you're paid if you're just average is much larger. So by choosing football, you're really kind of hedging, you're really betting on yourself, right? That you are going to have this long career. You are going to be a star quarterback and earn these much, much higher than average salaries in the NFL. Whereas if you just ended up being an average player, kind of baseball is going to be probably, quite a bit larger, right? 23 versus 7 billion. We're just looking at the average player, right? And then also, obviously, this is only income. So I'm leaving out a huge piece of this, which is, well, maybe I like to play football and I hate to play baseball, right? It doesn't matter how good I am, right? So the utility or the enjoyment coming from playing that sport is also going to have a dollar value to it. And that would kind of come in and factor into our decisions as well. Okay. And then also wanted to do that. I thought it was kind of a fun thought experiment and just playing around with some of the data. We can look at, okay, what sports, if I what percent of athletes playing at the high school level make it to the NCAA? This is all data coming from the NCAA. I'm a little skeptical. I think these look a little high, but, you know, I think this includes, Division II, Division III as well. Okay, so if you play baseball, there's a 7% chance that you get an opportunity at Division I, II, or III school. Okay? You can go through the different sports. Notice like men's and women's ice hockey is significantly higher. Probably this is like a supply issue, right? There's just not as many men's and women's teams, right? Every high school has a baseball team. I don't think a lot of them have kind of not, there's quite a few that don't have ice hockey teams, right? You could then take, okay, what's the probability of getting into these different divisions? And then you can see, oh yeah, it's a little bit low, vary a little bit across these. So relatively low that if I play in high school that I can make it into Division I programs. Right? What I could then do is think about, all right, what if someone was choosing to play a sport or push their kid into a sport and think about, well, what's the highest expected value? Well, first I would know the probability that if they play in high school that sport, what's the probability they make it to the NCAA? And then given that they play NCAA, what's the probability they make it professional? Well, they need both of those things to occur. So anytime we want to have thinking about the probability of high school going to the NCAA and playing at the NCAA, going pro, this is really going to be the probability of each multiplied by each other. Okay. So I could take those two probabilities, multiplying them by each other, and then multiply them by the expected starting salary for that sport. If I do that, right, I did it for the 4 major sports just because that's the easiest to get salary data on professional level. You can kind of see the average expected salary for a player in these sports, career lifetime earnings, and then probably you go, from high school to NCAA, probably go from NCAA to the pros. And multiplying that salary by each of those probabilities would give me the expected salary. And notice here, very, very low for these sports, right? If I start playing football in high school, the expected amount of money I can make is like $7,000 because the probability of making it the NCAA and then making it professional, that probability is so low, right? Like 0.06 times 0.01, we're talking about really, really low probabilities. Okay. And these are all like I said, I would imagine some of these are a little bit inflated, right? So here, you can see though, because that percent is a little bit higher for baseball, kind of keeps that up. You could replace this instead of making it to the minor league, you just threw out minor league players and it's like 0.04. So this is going to be cut in half by about $75. So I think what I want to do now, we'll come back to this on Friday. Let me see how much more I have. We'll come back to on Friday. Talk a little bit more about gambling on Friday as well. I put these up on, which one do I want to do? Let's do this one. I think we'll save the other one for Friday. I might dive into a little bit. So I had this data, and some of your projects are kind of similar to this, so this might be a little bit helpful. But I had attendance data, home, on the road, overall. I then looked at whether or not that team had legalized physical gambling or legalized mobile gambling. Okay? Now, I think I only have through 2018 to 2021. So I only have like 4 years. Actually, I think I might have also left out 2020 because of COVID. Yeah, I did. So I really only have 3 years of data where I'm going to have kind of good attendance data. And I guess I could have thrown 2022 and now I can go back out and kind of scrape this. So all I did here was put a 1 if that team state allowed online sports betting, or a 1 if they allowed physical, like in-person betting. So they might have very different impacts on attendance of the game. So I think about the mobile online sports betting. What's the thought process of why it might increase attendance? If I have money on a game, I have an increased kind of increased value potentially from seeing the outcome of that game, right? So maybe having this mobile online sports betting is getting more people invested in these games, making it more likely they might attend. I would love to see like TV view, like it's hard to get Nielsen data on like TV viewership, and it's not, you know, those numbers they put out are based off of like a subset, and they expand that to like the whole, considering the whole country has these same behaviors. But it would be awesome to see like what is happening to the number of views of these games. But attendance is kind of the best measure that we have here. Okay, so I'm going to think about, okay, how are the home attendance, right? Because the away games, like, it doesn't really matter if it's legal in my state and the game's being played somewhere else, right? So maybe that mobile online sports betting increases kind of home attendance. Now, for the physical on-site one, maybe it has a similar sort of effect, right? People are more likely to bet on the game, and even if it's not, you know, the game they're attending, right? It just gets them more involved in the sport, maybe increasing their interest. Okay. So what we could do is, okay, look, I'm going to use these two variables as my right-hand side or my independent variables. I then want to see how do these influence the total attendance of these teams. Okay, so I'm going to go to data analysis, go down to regression. My Y variable is going to be, total. And then my X variables are going to be whether or not they had legalized mobile and online sports or physical sports betting. Control shift, hit the down arrow, kind of selects the entire column for me. I selected my labels. I'll hit OK. We'll zoom in so you can see what I'm doing. Okay, so one thing that we haven't talked about up to this point, maybe a little bit of a refresher. So if I'm looking at this R squared, does anybody remember from 221 what that kind of tells us, or any other class? Yeah.
Variation in your dependent variable based on your dependent variable.
Yeah, it's a good interpretation. It's basically the variation that exists in the original dependent variable that is explained by all of your independent variables. Or you can kind of think about it as, you know, a more layman's term is, it's basically the percent of the variation we can explain in this variable of attendance. So we want that to be, I said it's percentage, sorry. The way that it's displayed here, it's the proportion of the variation, right? So we want it to be 100% or a proportion of 1. That's the highest R squared we could ever see. Right? And there's issues if you take the time methods, there's things like the adjusted R squared, and we worry about, you know, how many control variables included. But for the sake of this class, we're just going to be looking at that R squared. So R squared here tells us that we can explain what 0.007 proportion of the variation in attendance, or 0.7%. It's pretty low. Right, that we would like our R squared to be quite a bit higher than this to really be making some powerful statements. But just for the sake of this example, we don't have additional control variables in this data set. We'll just kind of go through and think about what the interpretation would be, even though we know that we have that pretty low R squared. Okay. So I come down here. First of all, I can kind of see, well, this is no good, right? My p-values are pretty high. They're not going to be less than any of my alphas of 0.1, 0.05, or 0.01. So I can't really say that either of these is having an impact on attendance. Right? Now, once again, like I don't know all other classes you've taken, but having larger sample sizes can help us kind of reduce our standard error in these estimates, and maybe we could then kind of say something with a significant level. But here, just based off of 3 years of data, we aren't able really to say that these is having any impact on attendance. Although the sign of our estimates are, we found evidence that looks like, yeah, it's increasing attendance. It's just we can't say at 90, 95, 99% level that it is increasing attendance. Right? So if we were able to, though, the interpretation would be holding constant whether the state has physical legalized gambling, having mobile sports betting would increase attendance on the whole season by about 14,000. Having physical in-person betting would increase by 27,000. Holding constant whether or not they had mobile. So, we can't put too much confidence in these estimates. We don't have a lot of additional control variables. Our squared is pretty low. Our p-values aren't low enough to be able to reject the null. But this would be kind of the, what you'd be working through, if you had like a similar question, right? So just to kind of reiterate something here as well. When I'm looking at these regression results. So we can only reject the null if our p-value is less than these different alpha thresholds that we set, right? Just a reminder of what the null is. We always start out assuming that that slope is equal to 0, right? That relationship between our x and our y variable is equal to 0. So if we can find a low enough p-value, well, we can reject that. Or what we're rejecting is, we're rejecting that there's no relationship. Or said differently, we found evidence that there is a strong relationship between these two variables. So remember, that's kind of always your null. You're always starting out assuming that all these slope coefficients are equal to 0. Okay. Any questions on that? Sorry if I pulled that off the screen too quick. I know I was still writing anything down. So let's do one more thing, I think, here. Oh, another thing I'll mention, just because we've got the data here. Might get out a little bit early today. What would be one concern if I'm using attendance data? Often better approach is some of these teams have different size stadiums, right? So if some of them are also selling at capacity and others aren't, well, if I'm selling at capacity, my state legalizes sports betting, can my attendance go up? No, right? I'm already hitting capacity. And so what we might want to do is something like look at the percent of the stadium that's being built, right? And see, does that increase? Now, we still have a problem with some of these teams that got 100% capacity, right? We still can't see an improvement in their attendance. So what we might do is kind of go through this. If I was doing this, right? I've already got this set up so that it's all filtered. I have the filter added on. Just a reminder how you do that. I'll hit Control-Shift to select the entire data set. Make sure I've got that filter selected. And what I would do, if it were me, is I'm going to say, okay, look, well, first what I'm going to do, because I'm going to delete some of this data, is select it all, copy and paste it on a different sheet so that I don't mess with my raw data. Okay. And they're going to throw a filter on this, right? Oh, actually, I wanted to only select this. The other were just labels. So I put a filter on it. Now I can start to delete things, right? So I'm going to look at this percent. I'm going to say unselect all of these. And then I don't even know how this occurs, but it's something about standing room only, that whatever the reported capacity is and what the reported is. So I'm going to select anything that's 100% or higher, because I couldn't really see a whole lot of movement in any of those attendance capacities. In fact, I might even be a little bit conservative. Like I could go down maybe anything that's below 99%, but for just the sake of this, we'll just look at anything that's already at capacity or higher. I'm then going to Control-Shift, hit the down arrow. Oh, maybe. Probably should have my mouse out instead of trying to use the laptop. There we go. I'm going to delete these rows, okay? Then I'm going to go back up to my filter, and I want it to show me everything. Hit OK. Now I'm going to go through, use that regression tool, select this home attendance, total, go back, select my sports betting, independent variables, hit OK. Zoom in so we can see the results. And what we can see now, well, my results weren't being driven by this fact, right? It wasn't being driven by that I still have p-values are even higher now, right? So sometimes, maybe restricting a certain group, I then go from not finding an effect to finding an effect, right? We kind of already talked about if that's the case, you can do it two ways. So let's say, let me think of an example that would be good to. So let's say I'm interested in the impact of sports betting on large versus small market teams, right? So I have some, population data along with this. I could run a regression for any team that has below, I don't know, 3 million. I don't know what the cutoff would be, right? But like some smaller kind of cities, right? Any city that has population below, let's say even 5 million. Right? I then run a regression for them, sports betting and their tenants. I then take my large market teams, I run a separate regression for them. That's one way I can pick up whether or not that effect varies between those two groups. What I could also have done, and either way is fine. So that's why I said, some of your projects, one regression could be fine, but you might want to do two. If I think about what I also could do is control for whether or not it is a large market. I'm also wanting to know, well, what's the impact of having this online mobile legalized gambling? But I think that this effect might be different for large market teams. We said, what could we do there? Use this interaction term, right? Now, this will pick up any additional effect that having legalized sports betting would have, or mobile legalized sports betting would have on large markets. So 2 different ways. You can separate the data out, run 2 separate regressions. One kind of problem with that is you're getting smaller data sets. We're going to lose a lot of our power, so our p-values are going to be kind of large, right? That's kind of what happened when I deleted all the other data, so the p-values went up by quite a bit. If I can run it all in one regression and include this interaction term, well, I can keep that sample size really high. Okay. Any questions on that before we keep moving? Okay. So what I'm going to do is once again just get you the full 10 out of 10 points for being here today. We'll kind of end a little bit early. I think on Friday, so I didn't put out a weekly reading this week. I'll have a paper that we're going to go through. We'll also probably look at Excel a little bit more, really starting to think about regression results and how we interpret them. Okay. All right. So once you get your recorded response in, you are free to go. I'll see you guys on Friday.